Example 9.3.1. Calculate the NPV, or net present value, of a one-year project. All right, so the setup for this one is your firm has the opportunity to invest in a project that will cost $500 today and yield $550 in 1 year. You estimate the project's risk-adjusted weighted average cost of capital at 6%. Your firm can also borrow and lend at 6%. What is the project's NPV, and should your firm invest in it? And how could your firm turn the NPV into cash today? Okay, so we've got two main parts to this one. One, we're actually going to calculate the net present value. And then two, we're going to walk through the process of how we can actually turn that net present value into cash in our pocket today by just how we arrange the financing for this project. All right, now this admittedly stylized and simple example is really just to explore the concept of what net present value is. And we'll see sort of the manual calculation and what's going on. And then the second part of it, how can we turn the NPV into cash today, is going to explore why it's such a powerful investment decision rule, because it is one of the most popular ones out there, and for good reason. A net present value will come up with a number for it. It'll be a dollar figure, and it will represent the value that a project creates, which will be equivalent to, if you were to accept the project, whatever the net present value is equivalent to putting that money in your pocket today, even though the project might have a life of 1 year in this case, or many more. So the basic idea we're going to start with here is, if you remember the value equation that we looked at way back in chapter 3, where just the value of anything is equal to its benefits minus its cost, right? That same sort of just value-based tool that we use to make all kinds of decisions. Well, net present value is exactly this, but now that we have the tools to recognize the time value of money, we can do the same value calculation with projects that have cash flows spread over time. Now, the definition of net present value, we've got a formula for it, equation 9.3 on our formula sheet. The NPV, or net present value, is just equal to the present value of the benefits, right? If those cash flows occur over time, we're going to discount them back to today's dollars. And we subtract from that the present value of the costs. So if they're cost to this project over time, we're going to discount them all back to today's dollars and then do this same value calculation just after taking care of the effective time value of money. All right, so NPV is just that guy, which when we see it right under the value equation, you can see that they're really exactly the same thing. Or in this case, we're calling it net present value instead of just value, because we're taking care of that time value of money portion of it, and then it's just the present value of the benefits minus the present value cost. So exact same thing here. All right, so let's start with the first part of this problem, and that is, it's a time value calculation. So we're going to follow our three-step process where we start by mapping out the cash flows. This project just happens to be a one-year project only, and so our cost to invest in the project happens today. It's going to be a cash outflow of $500 today, so we'll call it a minus $500. And then the benefit, what we would actually get, is $550 in 1 year. And I'm actually going to write that. I'm going to leave a space here and write the benefit down here. So that's a cash inflow of $550. And that is the benefit of the investment, or what we actually get if we were to give up the $500 today. And the other piece of information we have is that our weighted average cost of capital, our risk-adjusted WACC, in this case is 6%. So we'll put that up here. So that's the rate we want to use to do any time value money calculations. All right, now we've got a cost up front here at time period 0. We've got a benefit at time period 0. At the end of year 1, it's 1 year from today. And our cost of capital is 6%. That means if we invest this $500 today, our financial stakeholders expect a return of at least 6%, or we need to generate a return of at least 6% in order to pay our financial stakeholders the returns that they are expecting. So we know from previous chapters, these two cash flows, the 500 and the 550, are expressed in different units. The 500 is dollars today, $550 in 1 year. And before we can do any sort of direct comparison, we need to convert them both to either end of year $1 or today's dollars. Either way is fine. It'll lead you to the same conclusion. Of course, you'll just get slightly different values. But by convention, net present value is just going to put everything in present value terms. So what we're going to do is take this benefit and we are going to discount it back to time period $0. All right, and we can recognize that if we're looking at this benefit here, that's just a lump sum payment of $550, so we can use the present value of a lump sum. Which is equal to, the present value is equal to whatever the future value is, times our discount rate factor. And so in this case, our future value is 550. And our discount factor, our rate is 6%, so 1 plus 0.06 is 1.06. And then that goes out just one period, or needs to come back just one period to get it into today's dollars. All right, so that's 550 divided by 1.06. So we'll type that in. All right, and we are getting a value of $518 and roughly 87 cents. All right, so that means the benefit when we put it in time period $0 is $518.87. All right, and so now we can plug into our NPV. Got a little bit different setup here, so it's a little more challenging to write these out. All right, benefits minus costs, so our net present value, in this case, present value to benefits, is that $518.87, and that's expressed in today's dollars. And then the costs are also expressed in today's dollars, so we can do that subtraction directly. And we find that the NPV is equal to a positive $18.87. All right, so the NPV decision rule is we accept projects that have a net present value greater than 0. So if we come up with any positive number for the net present value, we would take that project. And if we came out with a negative number, that would mean the present value of the cost were higher than the present value of the benefits, and the project is not going to create value. It's actually going to lose value for us, and so we would not accept the project. All right, so the NPV decision rule is accept if net present value is greater than 0, and reject if net present value is less than 0. Since this guy has a positive net present value, we would accept this project and we would make the investment because we expect to create $18.87 in value for our owners. Now, one of the cool things about NPV, what makes it such a powerful investment decision rule, is that we come up with this number, in this case, 1887. And what I'll tell you is that taking this project on, so investing the $500 today and getting $550 in 1 year from the investment is equivalent to putting $18.87 in your pocket today. And in fact, the reason we're starting with this relatively simple example is that we can actually map this out. All right, so if we wanted to turn this NPV into cash today, there are 3 steps. And these same 3 steps apply, even for more complex problems. What we're going to do is borrow the present value of the benefits, invest in the project while pocketing the difference, and we'll see what that means in just a second. You're going to end up borrowing more than you actually need to invest in the project, and then use cash flow from the project to repay the initial loan. Right, so what would that actually look like in this case? Let's redraw this timeline. And need a little more space than that over here. All right, so the first thing we're going to do is we're going to borrow the present value of the benefits, right? And we already calculated that in step 1 here. So the present value of the benefits is $518.87. All right, so we're going to borrow that. And then we're going to invest in the project. That's going to cost us $500. All right, so we borrowed $518.87. We're only investing $500, so we net today $18.87 that we get to keep and do whatever we want to do with. Now, when we need to repay this loan in 1 year, right, we're going to have to pay it back with 6% interest. Well, so that means just finding the future value of this $518.87 at a rate of 6%. Well, we already know what that is because we got this $518.87 by calculating the present value. So the future value of it is going to be $550. Boy, this thing is not cooperating. Here we go. Minus 550. So we're going to repay that loan of $550, but we made this investment in $500, and we expect to have a cash inflow of $550 in 1 year. So we'll have that cash inflow of $550 that we can use to repay the loan, and so we have a net zero cash flow 1 year from today. So by arranging the financing this way, we put $18.87 in our pocket today, and we have a zero net cash flow 1 year from today. So we just took this project and converted it into dollars today, just based on how we're paying for the project. Now, would you actually do this? Maybe, maybe not. Some companies will do things like this. But mostly it's just a way to sort of build a theoretical construct and say, okay, this is what this project is worth to me today. And it gives you a way to rank projects based on their attractiveness, because the higher the net present value, the more value you expect that project to create. So if you're choosing among a group of mutually independent projects, meaning if you took one, you have to forego the others, you would, all other things being equal, just select the one with the highest net present value because it creates the most value for the company. Now, there are lots of nuances to that we'll get into over the chapter, but in general, that's the rough idea and why NPV is such a powerful decision-making tool. Now, there are a lot of simplifying assumptions we made here. One is that we can both borrow and lend at 6%, right? So our weighted average cost of capital is 6%, and we could also borrow and lend at that rate, so we just had the one discount rate to work with, whether we were going forward or backwards in time. That's just to make the math a little bit simpler and have fewer moving parts. The concept still plays out, even though for most of us you can borrow and lend at very different rates, right? It's going to cost you a little bit more to borrow than you can invest in most cases. But we can make that adjustment with a spreadsheet. It's a little more complex, but the idea is exactly the same, right? So that is net present value.